and this is the example for the sum of nth terms. Given AP is equal to 12, 20, 28, 36 and so on. The first term is 12 with common difference, 20 minus 12 it becomes 8. So, the sum of an arithmetic progression, as we know, Sn is equal to n by 2 into 2a plus n minus 1 into d. We have to substitute the values. So, the sum of that progression is 3690, that means 3690. And this is also another example. Given a is equal to 2 with common difference 2, and given the nth term is 200. And this is also another example for the sum of the nth terms. Here given a is equal to 2 and the nth term is 100. And this is, as we know that the nth term of an arithmetic progression is a plus n minus 1 into d, and this is the derivation of the sum of nth terms with a common difference. And we know that here you can see the model, which is the example for an arithmetic progression. So, here I am putting 1 to the first level and I am fixing 2 to the second level, and I am putting 3 to the third level, and I am putting 4 to the fourth level. So, what is this? Yes, this is an arithmetic progression. Here we are adding 1 to the preceding levels, that means here 1, then 2, 3 and 4. Here the common difference is 1, yes. Now, let us consider the sum of first and last terms. Do you know the mathematician? Yes, he was a great German mathematician. He was Carl Friedrich Gauss. His period is 1779 to 1855. Can you do the sum very immediately within seconds, about 1 to 100? Yes, he is the first person and he done very quickly the answer. Now, let us go to the applications of an arithmetic progression. So, these are the applications which we use an arithmetic progression in our daily life. So, an arithmetic progression means it is a pattern, and in our daily life we are observing the patterns of a maize corn, etc. And then, what is an arithmetic progression? Yes, an arithmetic progression means it is a sequence of numbers, and here we are exactly here to discuss about the topic, that is an arithmetic progression. And then the mathematical formula of an arithmetic progression is an is equal to a plus n minus 1 into d. And then applications of an arithmetic progression. Here in this session we are going to discuss about the applications of an arithmetic progression. And then Old Faithful Yellowstone National Park, and it is at the Yellowstone National Park, that is a natural geyser that produces long eruptions that are easily predictable, and surprisingly no one controls it. And then the time between eruptions is based on the length of previous eruptions. If an eruption lasts 1 minute, then the next eruption will occur in approximately 46 minutes. And if an eruption lasts for 2 minutes, then the next eruption will occur in 58 minutes. The eruption that thus occurs in the sequence of 46, 58, 70, 82, 94 and so on, with a common difference, that is 12. And then we are using this arithmetic progression in saving schemes. In saving schemes where you deposit rupees 100, 1000 or 100, and every year if you get an increment, that is rupees 50, thus forming an AP, that means an arithmetic progression. For first year you got 1000 rupees, for second year with an increment 1050, then 1100 and 1150. And we are using the arithmetic progression potato race. Ever seen a potato race? Believe it or not, there is an AP is applied even in a simple race. The distance difference between each potato increases in successful proportions. For example, 5 meters, 7, 8 meters, 11 meters and 14 meters and so on. And can you see the ladder building? Yes, the ladder building of a ladder with sloping sides, the length of each rung here would form an arithmetic progression. So, building of a ladder is also an arithmetic progression. And then, can you see the chairs of the theatres? Yes, there in movie halls, the first row of theatre has 10 seats and then the second row 12 and so on, then 14, 16, 18 and so on. So, this is also come under an arithmetic progression. Then more information about an arithmetic progression. Uniform increases in the speed at regular intervals and speed of an aircraft finding the sum of n terms of natural numbers, and then increase or decrease in the cost of goods, and then fare of tax. And when we travel in an auto, we have to give a charge. So, if the charge is per kilometer is 2, we have to give the fixed amount when we reach to our place. So, that is also come under an AP. And then finding multiples of numbers within a range, sales and production. Then these are some more uses of an arithmetic progression. Conclusion is, we have seen how an arithmetic progression are used in our ordinary day-to-day life, and we hope that now you will all look at life with a different perspectives. And here I want to conclude that an arithmetic progression is very useful for us. In every walk of our life, an arithmetic progression is, hello?
Swaro from Bellampalli.
Yes, hi Swaro, what's your doubt?
Can you say the sum of first 100 numbers?
Yes,
first
I can
100
say.
natural numbers?
Yes, my dear Swaro. Here I want to tell a magic. The sum of 1 to 100, 1 to 1000, then 1 to 10,000, then 1 to 1 lakh. And he is the mathematician Carl Friedrich Gauss. He is the first person who immediately gave the answer, the sum of 1 to 100. The sum of 1 to 100 is 5050, my dear friend. And here I can tell the easy way. This is the magic. That means 1 to 10 is the sum of the 1 to 10 terms is 55. That means this is the magic, that is there is 1 0. So, here I am not substituting any zeros. Here there is 1 0 and here I am not substituting any zeros, and then 1 to 100. So, there are 2 zeros. So, here I am sharing 110 to 115, that means 50, then I am sharing 10 to another 5. Then the sum of 1 to 1000 is, here there are 3 zeros. So, I am sharing only 2, here 1, then 2. And the sum of 10,000 is, here there are 4 zeros. So, here I am sharing 3 zeros to 5. And so on. Here in this way we can find the sum of the terms immediately, and he is the mathematician. We know that an arithmetic progression is very useful for us. So, while in every walk of our life, an arithmetic progression is very useful in cases of saving schemes, potato race, ladder building, arrangements of seats in theatres. And we also know that what is sequence, what is terms of sequence, and what is finite sequence and infinite sequence. Now, let us see again once we have let us see the levels of coins. So, there are here some levels of coins. Hello Swaro, what's your name?
Hi Swaro, this is Jasmine from Vaira, Khammam district.
Hi Jasmine, what's your doubt? Please tell.
I have a doubt.
Yes, tell me.
If the problem has given the fractions type,
yes. Here I am going to give an example, that is 1 by 4 minus 1 by 4 minus 2 by 4 minus 3 by 4 and so on. So, first we while we are going to find the nth term or the sum of nth terms, we have to subtract the second term and the first term. So, a2 minus a1. Here a2, the term is minus 1 by 4 minus 1 by 4 and the LCM is 2, then minus 1 into 2 it is minus 2, then minus 1 into 2, 2, that means minus 4 by 2, then 2 2s are 4. So, when we give a fractions also we can find an arithmetic progression by subtracting and by knowing the difference between the two numbers and the first term of an arithmetic progression with common difference, and we can find the sum of nth terms and we can find the nth term also. Observe here, there are some levels of coins, and in next step I am adding 3 coins. I am adding 1 coin to all levels. So, this is also progression. Now, let us see here the first term and the second term, third term and the nth term. These are the values A, and here I am adding, this is the first term of an arithmetic progression, and then this is the difference, common difference, that means A plus D, A plus 2D, then A plus 3D. So, the first term of an arithmetic progression is A, the second term of an arithmetic progression, here I am adding one difference. So, A plus D, A plus 2D, A plus 3D, and what is the nth term of an arithmetic progression? Yes, the nth term of an arithmetic progression is A plus n minus 1 into D. Now, let us see the example whether it is in arithmetic progression or not. Let us take one example. Given A is equal to 2 with common difference. Hello, Svero.
Hello.
Hello, sir.
Hello.
What's your good name, sir?
Hello.
Hello, sir. What's your doubt, sir?
Hello.
Hello, tell me, sir, what's your doubt?
Hello, this is Jayanuk from Serial School.
Hi, Svero. What's your doubt?
Hello, this is Jayanuk from Serial School. What is the difference between N and AN?
What is the difference between? Once again, repeat your question, Svero. Can you repeat the question? Hello?
Hello.
Can you repeat the question?
Hello, this is Jayanuk from Serial School. What is the difference between N and AN, sir?
N and AN. So, here we are considering the n terms and this is the first term. So, the difference is nothing but n is the nth term and we are going to find the nth term. That means, an is the term which comes at nth terms after many numbers. That means, A plus D, A plus 2D, A plus 3D and so on, A plus n minus 1 into D. So, the difference between the nth term we are going to find the last number, that means this is the general form of an arithmetic progression and we derived the formula as A plus n minus 1 into D. Did you understand the lesson about an arithmetic progression? Okay, once again we will see here, it is a model and this is, here I am adding 1, then here I am adding 2 and then here I am adding 3. So, this is an arithmetic progression and when you go out, there also you have to observe about arithmetic progression. Is arithmetic progression is involved there or not? Hello? Hello? Who is there? this is you have to check whether the sequence or a pattern or it is in arithmetic progression or not. And there is also in an arithmetic progression there is a geometrical progression and harmonic progression also. Let us discuss about that in next class. And we know that what are the uses of an arithmetic progression. So we have to apply the arithmetic progression in our daily life also. You have to observe very careful and about arithmetic progression, and I hope you all understood that whenever the problems came in public exams or competitive exams, you are going to do the sum because your friend Ashwini is tell about the chapter. Whenever the problem comes, you have to remember me and my formulas what I shared with you, so that there you can do the answer well, very perfectly. Hello Swero. Hello. Hello, who is there?
Hello.
Hello Swero,
Hello.
what's your name?
This is Rajkumar Saro from Dampeta.
Okay, what's your doubt?
Hello. I have a question here.
Yes.
See, the problem is if there are numbers like 3 comma 3 comma 3 mark 3 comma plus 3.
3 comma.
This number belongs to AP or GP.
These numbers are belongs to AP. And
Yeah.
arithmetic these numbers all belongs to AP and arithmetic progression, because here we are adding 0 difference. That means 3 plus 0 it becomes 3. Then 3 plus 0 it becomes 3. 3 plus 0 it becomes 3, 3, 3 and so on. So it is also come under an arithmetic progression. Once again, let us see the applications of an arithmetic progression. We use an arithmetic progression in our daily life by seeing in theaters, and then in ladder buildings, and then potato race, saving schemes with an annual increments, and then eruptions of time between based on the length of the previous eruptions. And then Old Faithful is a national geyser. It is at Yellowstone National Park that produces long eruptions that are easily predictable, and surprisingly no one controls it. And then what is the formula of this arithmetic progression? Yes, that is an is equal to a plus n minus 1 into d. Can you tell what is the sum of an arithmetic progression? Yes, that is Sn is equal to n by 2 into 2a plus n minus 1 into d. This is the sum of nth terms, and this is finding an nth terms. And today we are exactly here to know about an AP. Let us recapitulate what we learn. And in this session we saw what is sequence. What is sequence? Yes, sequence means it is a list of numbers in which there is a specific relation between two consecutive terms and which follows some order, that is in increasing or decreasing. Here you can see there is a 3 difference, and the 6 is obtained by adding 3 to the preceding term of 6 in this sequence. So here if I add 3 to the preceding term of 6, that means 3 plus 3 it becomes 6. And how we have to find the difference between two terms? Yes, we have to subtract from second term to first term, that means a2 minus a1. So 6 minus 3 is 3. We can also find the difference in that way, a2 minus a1. Then terms of sequence, we also discuss about terms of sequence. What do we mean by terms of sequence? Yes, terms of sequence means different numbers of a sequence is known as terms of sequence. Different numbers of a sequence is known as terms of sequence, and this terms of sequence is denoted by a1, a2, a3 and so on an. An is the term which comes at nth term, that means after many terms. And here 1, 2, 3 and n are the subscripts. The subscripts denotes the position of the term. The subscripts denotes the position of the term. And today we also discuss about finite sequence. That means a sequence which is countable is known as finite sequence. What is finite sequence? Yes, finite sequence means a sequence which is countable is known as finite sequence. Here we also seen that example, strength of the classroom. And then infinite sequence means a sequence which is uncountable is known as infinite sequence. Here we can also take the example, that is 10, 20, 30, 40 and so on. And today we also seen the levels of coins. Here we are adding the difference to the preceding levels. These are the differences. And what is an arithmetic progression? Yes, an arithmetic progression means thank you Swaros for listening my chapter, that is an arithmetic progression. An arithmetic progression is very useful for us, don't forget that. And remember me, I taught an arithmetic progression in Mana TV, and I am very thankful to our secretary sir because he given opportunity to me. As here today I am telling a lesson here because of secretary sir, that means R.S. Praveen Kumar sir. Thank you very much sir, and the teachers who prepared me, my maths teacher Ashim Babu sir, Padmaja madam, Sureka madam, Ramesh sir, principal madam, vice principal madam, they all look after me while I am preparing. So thanks to our teachers, and my friend Anusham, he's worked a lot for my preparation. So thank to all, and I also thank to my Monica sister who received us here.